Hello, participants. Am I audible?
Yes, ma'am.
Okay. Shall we start the session? Okay. Good morning to all. Myself, Asha M, Assistant Professor, Department of ECE, will be the session coordinator of this FDP. I welcome Dr. Saroj K. Meher sir for the session 3 of day 2 FDP on artificial intelligence. I welcome you, sir.
Yeah, good morning, ma'am.
Good morning. I welcome all the participants for the day sessions of day 2 of ATAL FDP on artificial intelligence. I welcome you all. Before we proceed, I'll give some instructions for the participants. To procure e-certificate of ATAL FDP, the following conditions to be satisfied. First condition is participant must have 80% attendance. Second point is a test will be conducted at the end of this FTP. Participant must score more than 60% as test marks. Then the third point is participants need to fill the feedback in AICTE web portal. So these are the three conditions which has to be satisfied by the participants. If participants, if you are having any queries or questions, you can unmute yourself and you can ask the question, or else you can put the questions in the chat box. So at the end, or the resource person is going to explain that. Okay. Then in the yesterday's session, sir explained about the artificial intelligence, machine learning techniques, and how to build the models on the data set. At last, he explained the applications of matrix and image processing. And also, sir explained that artificial intelligence, deep learning, and machine learning are linked with each other. And he also explained some mathematical models of the machine learning. In this session, the sir will going to continue the mathematical models. Over to you, sir.
Yeah. Good morning, everyone. Just I'm explaining all this.
Sir, yes, sir. You can take over the session, sir.
Yeah.
Yes.
Yeah. Hello. My voice is audible?
Yes, sir. It is audible, sir.
Okay. So I'm just sharing my slides. So as and when required, I'll use that board. So because if I start using the board from the beginning, so it will take a lot of time actually, because today I realized that, and because I need to write that on the board, and finally I need to explain and all the things, so it will take a lot of time, and it will not be possible for me to cover at least whatever I wanted to cover. So what I thought is that I just scribbled on the notepad, and I just scanned that, and I have put it on slides. And if you are having any issues or any problem, just let me know. I'll just explain those things on board.
Okay.
So I'm just sharing my slides. So today up to what time I'm allowed to speak, madam?
Sir, 11:30.
11:30. Okay. Okay. So I have put all this handwritten on board on the slide itself, so that it will be easier for me, and also it will be convenient for me to explain those things. So it is handwritten things. So if you are unable to read or unable to understand, just let me know. I'll make you understand. So it is handwritten one. I have just scanned that handwritten things and put it on the slides. Okay. So yesterday we are discussing about Just 2-3 minutes refreshing from the mathematical point of view. So what we discussed yesterday is that we need to learn about linear algebra, and we need to understand about multivariate calculus and probability theory. Okay, and we started to some extent the linear algebra, and from the linear algebra point of view, we have already discussed what is a scalar, vector, matrices, and we'll discuss what is a tensors is all about, and vector, matrix, norm, special matrices, eigenvalue, norms, eigenvalue, decompositions. And I have already discussed what is the need of mathematics and what is the need of linear algebra, because finally at the end of the day we have to represent our informations in the form of numbers, and machine can only understand numbers, right? So we need some ways to process that numbers, to play with those numbers, and in that sense mathematics is required. It's a mandatory kind of thing, but don't worry, we don't need to go to that level of mathematics, but very basics level of mathematics we require for machine learning, and that is what we are discussing. And yesterday we discussed about scalar, vector, matrix. These are the different representation of the numbers. How can efficiently you represent your numbers in terms of scalar, vector, and matrices? And finally the tensors. Okay, these are all representations only. Once you have represented that information in the form of numbers, and that numbers is represented in the form of vectors, matrices, and scalars, then it will be easier for the machine to process that, to work on that numbers, and for that mathematics is helpful for. Now, as we have already discussed, a signal can be represented in the form of a vector, a image can be represented in the form of a matrix, and many pattern recognition data sets can be represented in the form of a matrices and tensors. Okay. Now, as we have already discussed, scalar has single values, so it's a constant, it doesn't change. So let's say it doesn't have any dimensions. Vector has dimensions. That means in which direction it is going, either in the row direction or column direction. So it has one dimensions. So matrix has two dimensions. Okay, so that is what I was explaining yesterday, and like that we have matrix additions. Okay, once you have represented that information in the form of a matrix, then we follow that same operations: addition, subtraction, multiplication, and divisions. And vector additions, vector subtractions, matrix additions, matrix subtractions, we all know that one. Just to refreshing that one, because these are the way which help us to process the information. Let us say, as I was telling you, and with an example, let us say you want to increase the brightness of an image. Let us say you want to increase the contrast of an image or a video. So what you are doing, what your processor is doing, your processor is doing nothing but it is representing that image in the form of a matrix and adding some value to that matrix. So it's a matrix addition only. So increasing the brightness, increasing the contrast, histogram analysis, image processing I'm telling about. So all the things can be done with addition of matrices. Likewise, in signal processing also there are several operations: convolution operations, linear convolution, circular convolution. Then you have Fourier transform, you have correlations, autocorrelation, cross correlations. All the things are nothing but the playing with the numbers, and all these operations can be done with matrix addition, subtraction, and multiplications. So once you represent that information in the form of numbers, and that numbers if it is in the form of vector and matrix, then rest of the operations can be easily operated on that one, and we can get the result. That is where this mathematics is helpful for us. Okay. Now this matrix addition and subtraction we discussed, and this is how the matrix multiplications happens. We all know that. So if we are having two matrices A and B, so only condition you need to understand is that number of columns of A is equal to the number of rows of B. Then you can find out the multiplication of these two matrices and you can get the matrix C. For example, let us say you are having a matrix of 3x4 matrix. 3x4 means 3 rows, 4 columns. Okay, and B matrix is having 4 rows, 5 columns. So number of rows of number of rows of B and number of columns of A's are same. Okay, so that is the conditions you need to maintain, and that is how you can perform the matrix multiplication, and you are getting the matrix C. Okay, now that is why there is a very popularity. You know, MATLAB matrix laboratories, what we call it a programming language, what we normally use for machine learning and image processing, signal processing kind of applications. So what is that actually? That is nothing but the matrix operations, addition, subtraction, multiplications. So with MATLAB, you can perform the addition, subtraction, and multiplication very easily. You can play with these numbers. The moment you are telling that you can play with the numbers means you can perform several operations on that numbers. And those operations are nothing but processing the informations. Okay, this is how you can process the numbers and process the information and get the results. So that is the advantage of this representation of number in the form of matrix, vectors, scalars. Okay, now as we all know, matrix multiplications has certain properties. So we all know that these properties looks like very simple, but they are very useful for many kind of operations on for signal processing, image processing, pattern recognitions, and machine learning. Okay, so we all know what is a matrix transpose is, matrix symmetric vector. So now coming to the tensors. Now many people talk about tensors. So tensors is a very scary word, right? So tensor processing, tensor this, that, so many things we normally hear. Okay, but the tensors are nothing but a representation of the numbers only. Let us say one vector. As we discussed, what is a vector and what is a matrix? Vector has one dimension, matrix has two dimensions. Now, if we want to represent that in the form of a tensor, then it will be called one-dimensional tensor and two-dimensional tensor. So it's just a representation. Then on that represented matrix or tensors, you process the information. Okay, so like that, you can have four-dimensional tensor or five-dimensional tensor. So now why it is four-dimensional tensor? I hope you are able to see my mouse movement. Okay, so why it is four-dimensional tensor? Because this representation is having four dimensions. What are those four dimensions? See, it's a cube actually. So cube has three dimensions: x, y, z, and here in the long it is arranged in 1, 2, 3. So this is another directions. So it has four dimensions. So this four-dimensional representation of the information is nothing but 4D tensor. Like that, you have 5D, you have 6D. Like that, you can have multiple dimensions tensors because it will be very easy for the programming languages to process that information in a faster way. So that is the advantage of tensor processing. Okay, nothing else. Finally, you are using the same operations. Now coming back to the some of the other factors of linear algebra, we know what is the norm actually. So when we are talking about a vector, which is nothing but a some element. Now one thing I assumed that you followed that one. Let me ask one thing. Now this vector and matrix. Now what is a pattern and what is a feature here? Let us say I am having a vector x, and vector x has element small x1, x2, x3. Now what is the pattern and what is the features here? Can anybody respond my queries? Let us say I'm having a vector, okay, and that vector is nothing but let me come to the board. Now my board is visible.
No, sir.
Okay, just one second. Just one second. My board should be visible. It is not coming. Just 1 minute.
Yeah, it's visible, sir. Now.
Now but I don't know why I am not able to see that. Just 1 minute. Okay, now the board is visible. Excuse me, now the board is visible to all of you?
Yes, sir.
Okay, so as I was telling, let us say I'm having a vector x. Vector s is nothing but it has 3 elements, x1, x2 and x3. So it's a simple vector. Now how can I tell this vector in the form of a pattern? You know what is a pattern? A pattern is nothing but a set of features. So that is the definition of a pattern, right? So when we are talking about pattern recognitions, we need to understand what is a pattern. Okay, and that pattern is nothing but a set of vector, a set of element, and each element is a features. Now this vector x, which is consisting of 3 elements x1, x2 and x3, can I not say that this capital X is a pattern which consists of 3 elements x1, x2 and x3, and x1, x2 and x3 are nothing but the feature? So how do we represent a pattern in the form of a matrix? Sorry, in the form of a vector. So if we have to go for pattern recognition, machine learning and all these things, we have to represent that pattern in the form of numbers. And that number has to be represented either in the form of vector, matrix or tensor. Okay. Now if I'm having a, let us say pattern X, which has 3 features, X1, X2 and X3. So now I can call this representation is nothing but one pattern, where X1, X2 and X3 are 3 features. Let us say I'm having n number of features. Let us say I'm having n number of features. So this will be called as a X, as a pattern which consists of n number of elements. So it's just a simple vector. So if you remember yesterday, I was talking about one insurance company database. It was having 10 number of rows and 4 number of columns. So each row, each one vector. Each row, each one vector. We call it a row vector. And each column is also one vector. That is called column vector. So when we represent the information in the form of a database, each row vector represent one pattern and each column vector represent one feature. Okay, so normally if you read any books, the representation of this pattern is mentioned in this way. If anybody of you have gone through any of the pattern recognition book or machine learning book, you might have seen this kind of representations. This is nothing but a representation of pattern. X is a pattern. Because it's a pattern, it's a vector. So that is why that symbol on top it is there. Sometimes people use cap, sometimes people use this one, or sometimes put here. So it's a vector. So that vector is a point in n-dimensional Euclidean space. This is the Euclidean space symbolic representation. And this n is the dimensions, number of element in this vector X. So this is the representation of a pattern. Okay, anyway, so this is how we represent. Now coming to this point, norms. Norms is nothing but the magnitude of a vector. When I have already represented my information in the form of a pattern. Now what I am trying to do, I will try to find out the magnitude of that vector, of that pattern. So what is that norm? Norm, that is what we call it a norm, and that is nothing but the distance of that point from the origin. Okay, that is how we represent, right? Norm of a vector. Now what is the meaning of norm of a vector? Norm of a vector is nothing but it is the distance of that point from the origin. Okay, so it can be any dimensions. Fine. Now that norm in a generalized form can be represented like this. So that means you can see here on that slide, X is a vector where small p is represented as the type of norm, p norm. Okay, so you can put any value of p starting from 1 to infinite. If you put p is equal to 1, then these equations will look like this. Okay, but don't get confused with the symbolic representation of norm and absolute value. In absolute value, you put single bar here, but in norm we put double bar here. So just for the representation's sake, I'm just telling. Okay, so when p is equal to 2, that norm becomes a Euclidean norm. So when p is equal to infinite, then it will become a infinite norm. Okay, so then we need to find out the maximum value and all the things. Okay, so this is how we find out. If it is an infinite norm, then maximum of that value will be the output of that one. So that is how we find out the LP norm to find out the magnitude of a vector. Okay, so this is one another kind of norm that is called Favorin's norm. Okay, the size of the matrix can be measured with the Favorin. So there are different ways of representation of the informations are there, because at what time, what kind of representation of informations the machine learning model requires, accordingly we have to represent that information. Okay, now coming back to the another form of the matrix, we have already gained the knowledge of what is a diagonal matrix, what is a identity matrix. So you must be thinking that why this is so important, because this is much important when you are trying to process some matrix addition and multiplications. See, all the things actually, whatever we are discussing now here, matrix addition, subtraction, matrix representations, different format of matrices, matrix manipulations, matrix processing, you must be thinking what for we are discussing all the things, because here our prime motivation here is that when informations are represented in the form of a number and that number is in the form of a matrix, during processing, this matrix addition subtractions will act or will decide what is the computational burden of the processing steps. More is the addition subtractions, more is the computation, more is the complexity. That is what we normally count, right? We say, right, what is your computational complexity of the operations? So that operation is nothing but you need to count number of addition, subtraction, multiplication, and division. Okay. Now, more is the complex means more number of computations. Now, do you want more computation or less computation? See, it is clear that if you want to perform better, if you want to get good result at the output, your systems will be more complex. More complex system means your performance will be better, but more complex system leads to more number of computational complexity. More computational complexity means more number of numerical operations you are using. Okay, so our motivation here is that we want to get similar performance but with less number of computations. Now, how to achieve that one? That can be achieved by using this kind of representation of the number. If we represent that number in the form of a diagonal matrix, if we represent that in the form of a identity matrix or norm, all these things will actually help us to reduce the computational burden. Okay, so just to see, it is useful because multiplying by a diagonal matrix is computationally efficient. It requires less number of computation, less number of addition and subtraction, and that is how our computational complexity reduced. We are getting the same result, and that is what we want. Okay. So the advantage of diagonal matrix, as I mentioned here, computationally efficient algorithms are designed by restricting some matrices into diagonal elements. Okay. Now symmetric matrix, you all know that. Okay, Aij equal to Aj. If you perform the transpose of the matrix also, it will behave like the same thing. So one best application of the symmetric matrix is that I don't know whether you have gone through the convolutional neural network in deep learning architectures. In the convolutional neural network, or okay, if you have not gone to that deep learning platform, Let me tell you in the format of your signal processing cases. So when you are performing the convolution operations, see what is the difference between convolution operation and correlation operations? Convolution operations, as you all know, it requires 4 steps. Okay, time shifting, folding, point-to-point addition, and then point-to-point multiplication, and then additions. Then what is correlation? The difference between convolution and correlation operation is that in correlations you don't fold the system parameter. Folding, I believe you are understanding. Okay, so you don't fold the system parameter. Same thing is applicable for image also. When you are performing two-dimensional convolution operation, or two-dimensional correlation operation, this convolution and correlation difference is that whether you are using the folded version of the system parameter or unfolded version of the system parameter. And both convolution and correlation operations will be same if your system parameter matrix, if it is a two-dimensional, then it will be matrix. If it is one-dimensional, it is a signal, right? So whether you are using signal or image, accordingly you will have to work on either vector or matrix. Okay, so if it is a matrix, that means you are working in the image processing domain. Your image convolution and image correlations will be the same operation if you have used a symmetric matrix of the filter coefficients. So if you have taken a symmetric matrix filter coefficients, then with the same number or same type of operations, you can perform both convolution and correlation. That is the advantage of representations things. Okay. Anyway, then another thing is that what is a unit vector? These are all we have learned long back. Okay, so now we are trying to utilize those knowledge to machine learning, because machine learning requires this knowledge to perform the processing of the information in an effective manner. Okay, so a unit vector is a vector with unit norm. That means, let us say you are having a vector x, it has certain L number of element. Now if you find out the norm of that vector. Norm of the vector means nothing but magnitude of the vector. If the magnitude of the vector is equal to 1, then that vector will be called as a unit vector. So what is the meaning of unit vector? Unit vector is nothing but normalizing a vector. When you are performing or using the concept or term unit vector, what does it mean? Unit vector is nothing but equivalent to normalizing a vector. Now you believe, I believe you understand what is the meaning of normalizing a vector. Information normalizations. You want to bring the deviations, the variance of this vector as unit variance and zero mean. That is what meaning of the normalizations, right? I believe you are understanding the meaning of normalization. I don't need to tell more about the normalizations, because whenever you are processing some information, sometimes what happens is that some informations are in small range, some informations are in very high range. So whenever you are trying to process those small range information and high range information together, then there will be some kind of misunderstanding or some kind of contradictory activities happens between them. So to avoid that one, what do we do? Before processing that information together means that low range and high range, what do? We normalize both these informations. So that means bringing both the low range and high range to similar range. So that is the meaning of normalization. And normalization is nothing but finding out the unit vector. Okay. And this is one example of one unit vector. Let us say I am having a vector x equal to 1, 2, 3, 4. So it's a pattern. Okay, x is a pattern which has 4 number of features. Feature 1 each value is 1, feature 2 value is 2, 3, and 4. Okay, so find out the unit vector. That means normalize the vector. Normalizations will come like this. That means the vector divided by norm of the vector. Okay, so x divided by square root of 30. So you will get like this. For example, another vector, if you are having, I am having a pattern like this or a vector like this, which has 4 values 1, 1, 1, and normalization of the vector is this much. So why it is a unit vector? Because its norm is equal to 1. Okay, so this is how you can find out, and its magnitude is equal to 1. So this is the advantage. See, when you represent that any information in the form of a vector, all these possible properties of that vector will help you to process that vector in an effective way. That is the prime motivations. Another one is that orthogonality. We all know what is the meaning of orthogonal vector. When two vectors, see, vector means it has some certain directions, right? Row vector, column vector, x, y, z, whatever number of vectors you are having. So number of dimensions is equal to number of features you are having. Okay. Now, when do you say that two vectors are orthogonal to each other? When these two vectors maintain a 90-degree directions between them, like this. If x is a vector and y is a vector, both the vectors are perpendicular to each other. Then we will say the vector x and y are orthogonal to each other. And if you want to see the mathematical representation of the orthogonality, x vector and y vector is equal to 0. When two vectors x and y are orthogonal, that means this vector transpose and y vector is equal to 0. That means we use another way of representation that is called dot product of two vectors are 0. So if the dot product of two vectors are 0, that means two vectors are perpendicular to each other. That proof is already mentioned here. Just see, when they are maintaining a 90-degree things, what is the value of cos theta? Cos theta is xy divided by norm of x, norm of y. Okay, so this, if this is equal to 0, what will be the value of theta? Theta will be pi by 2. So that means 90 degree they maintain. Now you must be thinking, what is the purpose of discussing the orthogonality of a vector? Because it plays a very important role in machine learning. Orthogonality of a vector, let us say I'm having 5 number of vectors. Each vector represent one pattern. Okay, so 5 pattern, 5 vectors. These 5 vectors have 4 features. Okay, let me go to the board. Okay, let me go to the board. I'll show you. Let us say I'm having 5 number of pattern or 5 number of vectors. Okay. So 5 number of vectors is something like this. Let us say x1, x2 to 10 vectors I have. Okay, 10 vector means 10 pattern, and each of the vector has four number of features. Okay, that you understand, right? So it's a database. So it's a database which contains 10 number of pattern and 4 number of features. It is equivalent to the database what I was showing yesterday, that insurance database. Okay. Now see, it has 10 number of rows and 4 number of columns. Correct? These 4 vectors are nothing but the features. These 4 vectors are nothing but the features. Now, what is the purpose of the feature? As we have already discussed, features are nothing but the informations about the pattern. So let us say this element. So these 4 elements are informations about the pattern x1. So, okay, let me not write this one. So I am having a pattern x1. So x1 pattern has 4 features: f1, f2, f3, f4. Okay, so these 4 features expresses about the pattern x1. So that is how we represent a pattern. Now think about this one. When we take features 1, feature 2, feature 3, feature 4, and we want to process that informations for machine learning algorithms, what we expect is that these 4 features, because see, you have a row vector and you have also a column vector here. We expect these 4 column vectors should be independent to each other. So Those who are very new to machine learning, this kind of words may confuse, but try to understand here. When we are having a database like this, which is containing 10 number of rows and 4 number of columns, these columns represent features informations. Okay, these feature informations normally we expect means the model of the machine learning expect that those features are independent to each other. What does it mean? What is the meaning of independent features? Independent feature means these features do not maintain any kind of relationship among them. For example, let us say I'm showing one pen to you. So you are all able to see that I'm showing one pen to you. Okay. So this pen is an object, and this pen is also can be called as a pattern. Okay. Now let us say I extracted 4 features out of this. What are those features I extracted? Length, breadth, width, and weight. Okay. F1, F2, F3, F4. Length, breadth, width, and weight. Now you tell me, among these 4 informations, length, breadth, width, and weight, do you see any kind of relationship among them? Relationship in the sense, are they maintain some kind of overlapping informations among them? Can anybody put a views on that? We extracted 4 features: length, breadth, width, and weight of this object. Do you see any kind of relationship among these 4 informations? Can anyone? Please interact with me so that you will also enjoy and I'll also enjoy.
So they are related.
They are related. Okay. So we are not quantifying how much they are related, but they are related, right? Because this length and breadth and width are related to the weight, and weight is related to the length and breadth. Okay.
So they are not independent.
Yeah, they are. So that's why we call it a not independent. They are not independent. Now, what will happen if we don't have independent informations? If we don't have the independent informations, then we face a lot of problem in getting decisions about this pattern. For example, 1 minute. Now I'm showing this, let us see, 2 objects. I'm showing you 2 objects. Okay. And I'm extracting the same 4 features: length, breadth, width, and weight. Now, can you distinguish these 2 objects among them? With these 4 information, length, breadth, width, and weight, can you separate? Distinguish means, can you separate these 2 objects? Yes or no?
Yes.
How can you separate? Length, breadth, width, and weights, almost they are similar for these 2 objects. How can you separate these 2 objects?
Is it similar or is it?
It's similar. These are 2 marker pen, right? Two marker pens are there. So their length, breadth, width are same, or not same. If not same, it's very much similar to each other. So you cannot distinguish them. You cannot separate them.
Okay.
And your task is to separate them. Your task is to separate them, but you are unable to separate with these 4 informations. Why? Because these 4 informations are not independent to each other. They are dependent to each other. Let us say I am telling now, you separate that now. Now let us say you are taking one more features along the 4 features, that is color features. You are taking one more feature that is called color features. Now, will it not be very much easy for you to separate them?
Yes.
Why it is happening? Because that color information is completely independent to length, breadth, width, and weight. So you require independent information or dependent information to tell that these 2 informations or 2 patterns are different or same. So you require independent informations. So you got the point? So you require
Yes.
independent informations. These independent informations mathematically we represent as orthogonal informations. So I believe you are understanding now what is the meaning of orthogonality. So finding independent information is nothing but finding the orthogonal informations, and those informations are nothing but the vectors. So you got this applicability of the orthogonality. We all know what is the orthogonality, right? When two vectors perpendicular to each other, it is orthogonal. But in pattern recognition and machine learning, this plays a very important role. Because for the final target here is to take a decision on that one. As I told you, these two objects, you have to separate them. You have to take a decisions. How they are separate? They are unable to separate. You are unable to separate them with these dependent informations. You require independent informations. One is color information, another one is length informations. If you have these two informations together, it is easier for you to distinguish these two objects. And that independent or dependent informations can be mathematically defined as either they are orthogonal or non-orthogonal. Correct? So this is how you use this mathematical concept to represent the informations, and finally you can take a decisions. Okay. Now what is that orthonormal then? X and Y are orthonormal if X and Y are unit vector and orthogonal to each other. See, all the things, all the terminologies, all the concepts of this linear algebra, orthogonality, orthonormal, unit vector, norm, these are all helping us to represent the information in a correct format and to reduce the computational burden while processing them. Correct? So, another one that is called eigenvector and eigenvalues. You all have heard about that one, right? Eigenvalue decomposition. So what is those things? It is the process of breaking the mathematical objects into its constituents. The meaning here is that, let us say you have a matrix which represents a image. Now you know what is the meaning of image decomposition and signal decomposition. You all belong to EC department, right? You all know at least about signal processing. So signal decomposition means breaking of the signal component. If you perform a Fourier transform also, it decomposes the signal into, you know that one, right? What is the purpose of the Fourier transform? When we perform the Fourier transform of the signal, it decomposes the signal into small component, sinusoidal components. So that is what the meaning of signal decompositions. Now, without Fourier transform, can you decompose the informations in an easy manner? So that is why your Fourier transform is one of the mathematical operations you are utilizing to decompose the informations. Now the question is, why do we want to decompose the informations? Because most of the time what happens, when you are given a task and you are asked to perform a kind of solution to that task, first thing you do is that, you do means your brain does is that it will try to understand that informations, whatever it has come to it for processing. Okay. Now your brain will try to understand that informations, whatever input is coming to it. Now, if it is unable to understand that information properly, it cannot process it properly. And if it cannot process it properly, finally, your output will be it will come in a wrong way. You will not get the correct output. Okay. Now, the question is, if you are unable to understand that information at the input only, what are the ways you should use so that this information which is coming as an input, you should understand in a proper way? Okay. So what do you do as a human being? What do you do? Let us say I'm giving a problem to you and I'm asking you solve the problem. For example, let us say you are unable to understand the problem. So you are not able to provide the solution. Now, what is the option left for you? The option left for you is that, because this problem has become a big problem for me, what I'll do? I'll divide that problem into sub problems. I'll divide that problem into sub-problems. Now, what is the problem? Problem is in the form of informations only. So is it not the breaking of informations? So you break the information in such a way that the smaller component of the informations will be easily understandable to you. Same thing is applicable to machine also. Machine will always try to understand the information whichever is coming to it in the form of input. If it is not able to understand, you break that information. That is what we call it information decomposition. If it is information is in the form of signal, we call it a signal decomposition. If it is in form of image, we call it a image decomposition. Is it not the same thing as matrix decomposition or vector decomposition? Because we have represented signal in the form of vector, we have represented image in the form of matrix. So signal decomposition is same thing to say that vector decomposition. Image decomposition is same thing to say that matrix decomposition. And once you decompose these informations, then your model means your brain will make or will be in a position to put more effort to sub problems. That is why we call it divide and conquer. If you are unable to conquer, you divide that and conquer this. You all know, right? This is the rule these British people used and ruled us more than 200 years. Divide and conquer rule. That is what the meaning of signal decomposition. So for those decomposition of the informations, eigenvalue and eigenvector helps us. How? Let us see here. So as I told you, it is the process of breaking the informations. Breaking is decomposing the informations into smaller component. Okay. So like for example, 6 can be decomposed into two numbers like 3 into 2. I can decompose them into 4 plus 2 also. I can decompose them as 1 plus 5 also. These are all, I mean, just to make you understand what is the meaning of decomposition, I am just telling. 6 is a number. How to divide that number? Break them information into two components. 3 into 2. Okay. So like that, when you are having a representation of the information in the form of matrix, you can represent them or you can use eigenvalue and eigenvector to decompose them. Okay. Now let us see what is that eigenvalue and eigenvector. Just to refresh your memories. So if A is a matrix, then this matrix can be decomposed with the mathematical operations like eigenvalue and eigenvector. Okay. So capital V is the eigenvectors and lambda is your eigenvalue. I believe you can understand what is the meaning of eigenvalue and eigenvector of a matrix and how to find out the eigenvalue and eigenvector of a matrix, and determinant of a matrix also you all know. Okay. So now the question is how to utilize those concepts for our machine learning model development. Okay. So if you use these two concepts, then you are ending up with a equations like this. A is the matrix, whatever matrix we saw here, A, this is the same matrix here. Okay. A is the matrix which can be decomposed into three components. You see, V is the eigenvector, lambda is the eigenvalue. Okay. So V is one component, diagonal of lambda is one component, and V inverse is another component. So let us not discuss more about what is V and what is lambda usefulness. Let us try to understand that we could decompose this matrix into three different components. And what is the advantage? From these three components, we can get back your original A. That is what the meaning of decomposing the informations. We call it a eigenvalue decomposition. So you could able to break these informations. Let us say if your A is a image. So you break that image into three components like V, diagonal of lambda, and V inverse. So whatever you are doing, that all depends on what kind of problem you are having. Okay, let us not discuss that level now. Okay. Now, another beautiful thing about the eigenvalue and eigenvector, which is a relationship with that independent information and dependent information. Because I believe you understand now what is the dependent information and independent information. Okay. When you decompose a matrix into its eigenvalue and eigenvector is nothing but it's a vector. We are using a different name, eigenvectors, because eigenvectors and eigenvalues, they are related. So for each eigenvalue, you have one corresponding one eigenvectors. Okay. Now there is a very beautiful properties follows if you find out eigenvalue and eigenvector. What is that? These eigenvectors, whatever you are getting from this matrix A, are orthogonal to each other. These eigenvectors, whatever you are getting out of the matrix A, is orthogonal to each other. The meaning here is that, just see the board. In this board, as I showed, 10 rows and 4 columns. 10 rows represent 10 pattern, 4 columns represent 4 features. What we expect? We expect these 4 features should be independent to each other. But we found for these 2 pen examples, whatever I shown, then you are not getting these 4 features as the independent informations. So what you did? You took one more information, that is the color information, to make it whole process as independent. Let us say you don't have that option to take one more features like color features. What will do? See, is it not a matrix? This database, is it not a matrix? 10 cross 4 matrix. And this matrix represents one database. Okay. You want these 4 features to be independent to each other. F1, F2, and F3, F4. So what you can do? Just find out its eigenvectors. How many eigenvectors you will get? 4 eigenvectors you will get, corresponding to 4 eigenvalues. Those 4 eigenvectors will be independent to each other. And if you get the independent informations out of these 4 features, then it will be easier for you to take a decision on these 10 patterns. And that you want that one only. You expect that one only. So this is how your eigenvalue and eigenvector helps us to find out independent or dependent informations or variable, whatever you can see. Okay. Now some properties it follows. I think you all, if you remember refresh your memories, you can understand these terminologies. A matrix is called singular if A and A transpose is not independent. Inverse doesn't exist. Now you may ask, what is the purpose of discussing this singular matrix, non-singular matrix? Then you will have another term called semi-definite matrix, positive definite matrix, non-negative definite matrix. See, these are these different properties of matrix which will help us to understand the information in a very easier manner. Okay, that is what the motivations. I'm not going to much about these 2 things. So I'll just quickly move to the application of these things, because you all know in machine learning domain, we normally talk about the probability density functions. Okay. So this probability density functions, whenever we try to find out, it maintains 2 properties. These are the mathematical terminologies. The probability density functions value should be greater than 0 and area under that curve is equal to 1. Okay. Then only you can find out the distance between the 2 vector or 2 pattern. Okay. Let us, it may confuse you, whatever I just now told, but as a beginners, you can think about that one day. When you are having 2 pattern, okay, let me go to the board to make you understand these 2 things, particular concept. The same thing, whatever just now I told. Let us say I'm showing you 2 objects. You are able to see 2 objects. One is the pencil, and another one is the marker pen. Correct? Now, if I'm asking you, you tell me what are those objects and how they are different to each other. You can easily tell. You can easily tell that. Why you are able to tell that? Can you ask your brain how your brain could answer this question? When I'm showing a single object, let us say this, and I'm asking you, tell me what is this object, you can easily tell that this is nothing but a marker pen. You can able to see that. You can tell that also it's a marker pen. But can you tell me how your brain could get this answer? Can anyone tell? How or what makes your brain to tell that this object is a marker pen and this object is a pencil?
Because already it is known.
Yes. You know that these two things are happening. Okay. Now, why you are, if, let us say if I am showing this pen to a small kid, let us say if I am showing this pen to a small kid, do you get the similar answers from that same kid? Whatever answers you can give, that kid may not be in a position to tell that this is a pen. Right? Why? Because that kid has not learned. What is the meaning of learning here? Here, learning is again coming to the pictures. You are able to tell that this is a marker pen because you have already trained your brain in such a way that anything which looks like this is nothing but a pen. Are you getting my point? Anything which looks like this is nothing but a pen. What does it mean? That means your memory, your brain has already established one pattern which is belonging to this pen. Correct? Your memory or your brain has already stored one information about this pattern. When I am showing this pattern to you, your brain is actually matching this pattern with your stored brain. You got the point? When I am showing this pen to you, your brain is matching the previous pattern with this pattern. And if it is matching, then your brain is telling this is a pen. When I am showing this object, you can say that this is a pencil. Why? Because your brain has already stored the information about a pencil. So it is just matching that. And in machine learning terminology, we call it as a similarity matching or dissimilarity matching. So what is the meaning of similarity matching and dissimilarity matching? When two objects, how much they are similar and how much they are dissimilar. You know Euclidean distance, right? We all have read those things in our high school level mathematics or 10+2 level mathematics. We all know that Euclidean space or Euclidean distance. We all know that. What is the meaning of Euclidean distance? The distance between two vectors. Okay, that Euclidean distance is nothing but, I have already shown you that Euclidean distance. That Euclidean distance is that I have already shown you. 1 minute. Yeah, this. Yeah, see. Euclidean norm is nothing but your Euclidean distance. When you are having two vectors, x and y, find out the Euclidean distance between these two vectors means you are finding out the Euclidean distance between these two vectors. You know that how to find out that one. That this is what the equation is. Xi minus yi square and sum of them and 1/2. That is what the Euclidean distance. Okay. Now, in what way it is helpful for us in machine learning? This Euclidean distance helps us to find out the dissimilarity matching between the two objects. When I was just now talking about matching your brain information and the information whatever I am showing, your brain is matching these two things. If they are matching, they are coming nearer to each other, then it is telling what kind of object it is. So for that one, we use this Euclidean distance or Euclidean norm. And that is how the importance of norm is coming into the pictures. So if your Euclidean distance is less, that means they are less dissimilar. Less dissimilar means more similar. So they are matching to each other. You got the point? Okay. So now coming back to that. Yeah, probability density function that we'll discuss a little bit later. So a set of eigenvector of A, each corresponding to different eigenvalue of A, is linearly independent set that I have already told you. Okay, so your eigenvectors are independent set. That means independent informations. So you could able to decompose the dependent information into independent information. So you got the advantage. So that is why we take the help of mathematics and linear algebra. Okay, and those concept of eigenvalue and eigenvector is very much useful to find out the principal component analysis. I'll not go to that part actually. I believe, or I have to assume now, at least for this shortage of time, I am assuming that you know principal component analysis. Do you know principal component analysis? What is that? Anybody?
It's PCA.
PCA, yes, PCA, principal component analysis. Okay.
So like if there are more number of features, we will try to select important features from that using principal component analysis.
Correct. But that is not the prime motivation of the principal component analysis. Prime motivation of principal component analysis is to convert that dependent information into independent informations. We use another term, correlated information or uncorrelated informations. That is the prime motivation of principal component analysis. After doing that, then you extract whichever feature is you are requiring. That is what we call it feature extractions. Okay, but the feature extraction is not the prime motivation of PCA. Prime motivation of PCA is to uncorrelate the information. Uncorrelate is nothing but make it independent to each other. Okay, so your eigenvector and eigenvalues helps us to find out the principal components, because principal component analysis are nothing but you need to find out some component. We call it a principal component. First principal component, second principal component, third principal component. And how many number of principal component you will get? It is equal to the number of features whatever you are having. And after principal component analysis, the beauty of the principal component analysis is that each and every principal components are independent to each other, uncorrelated vectors or uncorrelated information. And that is what you want. That is what your model want. Correct? Anyway, next coming back to the calculus part. We all know that integrations and derivations. Okay. So these integration and derivations are very scary things actually. But we need to ventures into these things in a very preliminary level. Simplest way we need to understand what is the derivative and integrations, because these are the, you can say, two basic and very important components of machine learning algorithms. These two things normally comes into the pictures when you are talking about the learning of the machine. What do we mean by the learning of the machine? Yesterday we discussed already, right? Learning of the machine is nothing but adaptivity. Learning of the machine is nothing but adaptivity, changing. Okay. So to perform that changing, we need to take the help of calculus. There is no other way left for you. There is no option left for you. You have to use that one. Okay. Let us see how it is happening. Okay. So very quickly, I'll just move to this particular calculus and derivative, and I'll spend more time on the application part. Okay. Just see for the refreshing your memories, what is a calculus and these things. Okay. So the derivatives are nothing but we call it it has a geometrical meaning and it is a physical meaning. Derivative means slope of a curve, correct? And the physical meaning is rate of change. Okay, rate of change of displacement is variable. Velocity, rate of change of velocity is equal to acceleration. We have already read those things in physics, in 10+2 physics. Okay, and in geometrical aspects, if you want to see what is the derivative, it is the slope of a curve that we have already read in our class 10. Okay, but we never realized its application in machine learning. Okay, without this you cannot define machine learning also. Okay, so the basics of derivative is that d by dx the change in variables with respect to some variable. That is what the meaning of derivatives, and that is what we call it slope of a curve. Curve is the functions. Okay, the change in functions value at a particular point. That is what the meaning of derivative. Okay, so the power rule and mathematical rules are there, and these are called derivative rules. How to find out the sum of derivative, product derivative, and all the things. Then what is a chain rule, and these things. Then coming back to the partial derivative. Okay, so partial derivative is nothing but when you are having more than one variable and you want to find out the derivative of any one of the variable with respect to the other independently, then we call it a partial derivative. Okay, that you all know, so I don't spend much time on this. Then same thing in integrations also. It is a different concept. Integration is required when you are talking about the probability theory that we'll discuss a little bit later on. And integration is nothing but the area under a curve. Okay, so I'm just quickly, we have a definite integral, independent integral. So just refreshing your memories only. Okay, so like that, then finding out the gradient. Okay, so gradient is nothing but the partial derivative with respect to one variable with the others. Okay, now let me come to the board and make you understand what is the applicability of this derivative and integrations. The same thing you are using for adaptive filter also. Okay, if you remember yesterday I was talking about, if this is the xn, it goes to a system st and it gives you the output yn. Yesterday we discussed, right? So this can be either a filter or a machine. In signal processing we call it fixed filter or adaptive filter, or in machine learning we call it a machine. And if the filter parameters changes, we call it adaptive filter. If the system parameters changes in terms of machine, we call it a machine learning. Okay, otherwise conceptually both are same. Okay, now what happens here is that when xn goes to your ht and gives you the output, it is nothing but something like this: y is equal to function of x. This f is nothing but your h, x is your this one, and y is your this one. So finally you are trying to map between input and output. Okay, now the question is, now the problem is, when you are giving some input and processing them through h, the system parameter, you will get some output y, because this h is not known to you initially. For the adaptive filter scenario I am telling, because for the fixed filter you know that what is your ht. We are not talking about the fixed filter, because fixed filter will not be helpful for the real-time scenarios. Okay, we are talking about the adaptive filter. Okay, so in the adaptive filter, what do we do? For each input, initially we take some random values of the system parameters. Okay, so the moment you are taking random variables here, random parameters here, you will get a random output y. For each input, you will get some output. Then when you are getting output, this output is different from what you are expecting. Why it is happening? Because this ht is different for you. So what happens? Here we use a dn. dn is nothing but your desired output. For each xn you are getting one yn, but for each yn there is a corresponding dn which you require, but you don't get. So yn is called estimated output, dn is called target output. So initially what happens? Both the things will deviate as much as possible. They will not be equal. They are totally different from each other. Why it is happening all these things? Because your st parameter is random value. So what do? You make a deviations here and you find out en. En is nothing but the deviation. En is equal to dn minus yn. These are all things you do in adaptive filters, and same thing is applicable to machine learning also. Okay, so once you find out the en, this en goes to here and change the parameter of the ht. This is what you do in adaptive filter, and same thing is in machine learning also. Now, how to do that? How your En is going to change your Ht? Here, you have to take the help of this mathematics, that is partial derivative. This calculus factor will help us to do that. Now, how to do that? See, in machine learning or in your adaptive filter, we call this error is as a error function or a cost functions. Okay, so it's a function. Now, what do we expect here? Your En should be nearly equal to 0. That is what you want. The moment your En is very nearly equal to 0, what does it implies? It implies Dn is equal to Yn, and that is what you want. When these things will happen, that means the moment you can minimize this error value to 0, your purpose is fulfilled. And for that reason, we require this calculus. How to do that? This becomes a kind of function minimization. There are two kinds of optimizations, you know, right? Function maximization, function minimization. Here, this function has to be minimized so that it will be equal to 0, so that Dn is equal to Yn. Now, who is responsible for this En? Why En is more? Because of the random Ht. So what you have to do? You have to find out the partial derivative of this cost function En with respect to the filter parameter. That means, how do you find out derivative of En with respect to Hn? So partial derivative of error function with respect to the corresponding parameter who is responsible for En, if you can make it minimize or 0, then that equations will help you to change the parameter of Hn. And normally how we can write? Ht is equal to Ht minus 1 plus change of Ht. Present value of filter parameters or system parameters is equal to previous value plus some change. This change is nothing but the gradient vector. This is the gradient symbol, right? And these gradient symbols, you can get it from this equation. The moment you can end up with a small, see, this En you can expand. What is your En? Dn minus Yn. What is your Yn? Dn is fixed, right? Yn is nothing but the processing of the input xn to this one, this convolution operation or whatever operation you are having. So finally, if you break everything, you can find out, or you will end up with a kind of small equations. And that equation you put it here, then you can change your weight parameter. And that is what you do in adaptive filter, and same thing is applicable to machine learning also. Okay, now you understand what is the applicability of the partial derivative, gradient, and calculus in machine learning and adaptive filter. Okay. So I'll just move to the probability theory within 10 minutes. Then we will have a kind of sessions, question and answer sessions. Okay. Okay. So probability theory. What is the definition of probability? We have all read those things in 10+2 level. Statistics and probabilities. So probability means it provides a way of quantifying the uncertainty, the measure of uncertainty. Why we want to play with the uncertainty term now? What is the meaning of uncertainty? Uncertainty means which is not certain. Let us say I'm telling this information is uncertain in nature. This information is uncertain in nature. What does it mean? That means this information is not clear to me. I am unable to understand these informations. So the moment you have a certain information, that means you can understand the informations. In real-time data, real-time scenarios, most of the informations are uncertain in nature. So to deal with the uncertainty, we require this probability theorem or probability theory. This mathematics helps us to measure or to quantify that uncertainty level. See, let me give you an example of what is the meaning of uncertainty. let us say the same examples. Let us say I'm showing one that pen to you, and I'm asking you tell me what are the possible lengths of this kind of pen. What are the possible number of length of this kind of pen? What will be your answer? Will it be 1, 2, or 3, or 9, or 10? Which one is correct? Which one is correct? Can anyone respond to that? When I'm showing one pen to you and I'm asking one question, something like that, you tell me how many different types of pens you can have or you have seen till today. Can you give me one fixed answer for that?
There is no definite answer to that.
There is no definite answer for that. That is the meaning of uncertainty. There is no certain answer for that information. That is what the meaning of uncertainty. So I wanted to give you a feel of how do you understand how you mean, what do you mean by the uncertainty informations. Okay, so real-time problems are highly uncertain in nature. That is why most of the time the statistics and mathematics somehow cannot deal with the uncertainty behavior of that one, this probability theory and all these things. So for that reason, we need to go for the computational intelligence thing. I believe you all are understanding what I mean to say. Computational intelligence thing means the computations which can handle better the uncertain information. For example, your fuzzy set theory, Rob set theory, and all the things, even neural network. So these are the tools which helps us to measure the uncertainty behavior of the information in a proper way. It can handle the uncertainty behavior, and the model which can handle the uncertain behavior, that model can take the better decisions. Okay, so anyway, the motivation behind the probability is that it provides a way to quantify the uncertainty. It also helps us to analyze the behavior of the decisions of AI or machine learning, which are uncertain in nature. Okay. So why uncertainty? As I have already given one examples. Here some more examples are there. Inherent stochasticity in the systems being modeled. Examples: model of a quantum mechanics. Incomplete observability. We do not have or cannot have observe all these characteristics, functionalities of all variables. As I told you, when I'm showing a pen to you and I'm asking how many types of pens you have seen which are of different length. It is a limited one. Maybe somebody may answer that one as a 10, somebody may answer a 20, 30, 40. But what is the correct answer? Infinite is the correct answer. That means, what does it mean? Let us say, let me give you one more example for that one. Let us say there are two people are there. One people is X and another one is Y. X has seen 20 variations of pen. Okay, 20 variations of pen. Variations means you are understanding different length, breadth, width. That is the meaning of variations. Person Y has seen 100 variations of pens. You got my point? X has seen 20 variations of pens. Y has seen hundreds variation of pens. Okay. What does it mean? What is the meaning of seen? Means X has learned 20 variation of pens. Y has learned 100 variation of pens. That is what the meaning of seeing, right? Okay. Now I am showing one more pen to both of them. Who can provide the better answer? X or Y? Please tell anybody. Who can provide the better answer? X or Y? X has learned 20 variations. Y has learned 100 variations of pens. Now, if I'm showing one pen in front of them, who can provide better answer?
Why?
Y will be better answer. Why? Because that clarity of information is more with Y than X. X has seen only 20 variations. Y has seen 100 variations. So now you are understanding. When you are learning, that learning should be complete in nature. But when that complete learning will happen? When you have unlimited information. That means you have seen unlimited number of variation of pens. Is it possible practically? It is not possible practically. So that is why our informations are almost uncertain in nature. So the more certainty of learning, more certainty of informations is with you, the better decisions you can take. Okay. So third one, incomplete modeling. When you are modeling something, modeling means writing or processing the informations. We see there. You just read this statement. We use model that discards some observation information just because we cannot handle or reason it. For example, simplified.
Hello, sir. Saroj, sir, your voice is not audible. Saroj, sir.
Okay. Am I audible to all of you?
Yes, sir. Yeah.
Okay. There was a problem in my microphone, so that is why it was muted.
Okay, sir. Okay.
So I am just sharing that one. I was using a external microphone and the battery gone down. So that was the problem. So I am changing that microphone now. So you are able to see my slide and my voice is audible to all of you?
Voice is audible, sir.
Okay. So
yeah, slide is also seen.
Let us continue. So I another 5 to 10 minutes I would like to take and then we'll close.
Okay, sir.
So we are discussing about incomplete informations, right? So incomplete informations or incomplete modeling actually it actually makes us put us in a troubling conditions. Okay, and that is why we cannot take the better decisions. Okay, so what is the meaning of here? What I am trying to say is that the message is that your uncertainties are there in each and every step of your decisions. Your input information is uncertain, your observations are uncertain, uncertain is incomplete, your modeling concept is also a incomplete one. Now, when you are dealing with all possible types of incompleteness or all possible type of impreciseness, then how can you expect a good result? So obviously your output will be hampered. Your output will be error, full of errors. Okay. Now what is the options left for you now? The only option left for you is that try to understand what are the levels of incompleteness are there in your observations, in your input informations, and in the modeling part. And for that, probability theory helps us. Okay. So probability is nothing but the measurement of uncertainty. You can understand or you can easily say that this is the level of uncertainties are there, because when you will get some solutions, first thing is that you need to understand what is the problem. When problem is not known to you, you cannot find a solution. So first of all, try to understand what is the problem. So how to know this? What is the problem? Problem is the uncertainty. But what is the level of uncertainty? That we need to know, and for that probability theory helps us. Okay, so this is how we measure the uncertainty level and try to reduce those things with the different processes, right? So there are various kind of probabilities. Like one is frequency based Bayesian probabilities. So I will not go to that part because it will take much time for me. So anyway, I believe I could provide a kind of initial motivations. What is the purpose of mathematics and all the things, and what is the use of probability theory, calculus, and linear algebra. So I'll just skip this one. Now in probability theory, there are another term called probability distributions. Okay, so probability distributions can be of discrete type and it can be of continuous type. Those who have already done or already developed any model in machine learning, those people can easily understand what is this application of probability distribution functions in the development of machine learning algorithms. The basic algorithm, I can name that one is that Bayesian algorithms, Bayesian classification model. Okay, so these are all the classification model which you can develop using the probability concepts. So without the probability theory, you cannot develop this classification models. And let me tell you, this Bayesian classification model is the basic model. So whatever models, classification models or clustering models or whatever models you can ever think of, all models are directly or indirectly have come from this Bayesian classification model. Okay, and this Bayesian classification model is completely based on probability theory. So now you can understand at least that what are the significance of this small thing, probability theory, calculus, linear algebra in the development of the machine learning models. Okay. So type of probability distributions, you all know that joint probability, uniform distributions, and all the things are there because when you are finding out the probability density functions, that means you are trying to see that your informations are equally probable occurrence or not. So your informations are equally probable or not. It is something to say that, let us say I am tossing a coin. Okay, so how many possibilities are there? One is head and one is tail. Okay, so that I can say probability of coming head is 50%, probability of coming tail is 50%. So what is the probability? 0.5, 0.5. Okay, let us say I tossed the coin 10 times. Let us say I tossed the coin 10 times. Now, will you get 5 times head and 5 times tail? Will you get 5 times head and 5 times tail? You will never get. Either number of head will be more or number of tail will be more. Now, when it is possible to get equal or nearly equal amount of head and tail? Can anyone respond this? I tossed the coin 10 times and I am not getting equal number of head and equal number of tail. What should I do so that I will have equal number of head and equal number of tail?
So bring in bias into this model.
No, I'm not talking about the model. I'm just talking about the probability concept actually. When I'm talking
the number of trials.
Number of trials, what happened?
10 to infinity.
Yes. If you increase that number of trials to infinite, then that
number of trials 10 to infinity.
Yes, correct. What you are telling, that is correct. Infinity, then probably you are in a position to get equal amount of head and equal amount of tail. That is what we call the equal probable values. So when you are taking information as the input to the model, that information should be equally probable values. To get those things is, I mean, talking about those things is very easy, but getting those things is very difficult things. So you should always try to take these input informations which are equally probable in natures. Okay. So these are the different concepts. So some of the applications of probability density functions, linear algebra and matrix algebra in the distance measure. That means the similarity measures or dissimilarity measures. That is here. I will try to share these slides if you want. So this is how the probability density applications can be useful for model development, because you know, some kind of distributions we use, like Gaussian distribution, normal distributions, many kind of distributions are there. So we assume one kind of distributions of the data so that it will be helpful for us to define any kind of machine learning models. So how to do that one? So what kind of assumption we should take? So all the things are there, and that is how the applications of mathematics comes into the pictures in machine learning. I believe time is up now, so I'll stop here. If you are having any queries, questions, any concerns, please let me know. I'm here to answer your queries. And if you want to have any kind of queries, only things later on, please drop a word to this email ID. I'll be very much happy to address those things.
Hello. Participants, do you have any questions?
See, the purpose, what I was expecting is that out of this discussion, if at least one or two participants, audience, come forward to go for the next level of working in machine learning with it. I mean, if you want any kind of collaborations with our institute or with me, that would be more fruitful. That is what my belief was, and I hope at least one or two audience out of this number of audience, whatever number you are having, expect at least they should go forward to work on this machine learning and all things. It's very fun, and you will enjoy a lot in this kind of model development and in this domain of research. So I welcome all of you if you want to have any kind of future collaborations with our institute or with me. Yeah. Any questions? Any queries?
So one query I had.
Yeah, please.
The concept of 5D tensor which you explained, could you just explain it once again? Because I'm not very clear about why it is 5D.
Tensor concept is nothing but representation of the information in the form of number. Okay. See, your vector matrix. What is your vector? Yes. Vector is having one dimension.
One dimension.
So either in the row vector or column vector. Matrix has two dimensions. Both row and columns are there. So if we want to convey that one in terms of tensor, that vector will be called as one-dimensional tensor. Matrix is called as two-dimensional tensor. Video is called as three-dimensional tensors. So tensors are nothing but it's a kind of representation of your number. Once you have represented your number means nothing but your information. Once you have represented the information in the form of tensors, your programming language actually can play with this number in an effective way. So this is all about the representations, nothing about the processing. So it will not hamper. You may not do the tensor representation also. You just manage with your matrix representation and you can develop any kind of model. You don't go for tensor. When your complex algorithm you are developing, your data set is complex, probably to make your work easy, you can go for tensor representation. That's the only concept. So it's a representation. Just don't get confused with the term tensor. It is nothing but it's a representation of the informations. The way you are representing matrix, tensor is also one kind of representation.
My is like cube is 3-dimension, and when we put 3 cubes, why it is becoming 4D tensor?
Yeah, I'm just coming to that slide. My slide is visible to all of you?
Yes, it is.
Okay, just 1 second. Yeah, you are talking about this one?
Yes.
Yes. Let's see. A vector is one dimension. Okay, because it has one dimension, so we can call it a one-dimensional tensor. Matrix is two-dimensional tensors. A image is two-dimensional tensor. Now video is a three-dimensional tensor. Now how it is 4 dimensions? Each one having three dimensions. Here and temporal. 3 dimensions here. If you are arranging them into one more directions, those that becomes 4-dimensional tensor.
Okay. It has nothing to do with the number of cubes you have arranged. It
No,
can
no.
be more
It
also,
is
right?
nothing to do. You can put 100 cubes or 3 cubes or 4 cubes. Now, if
Right.
you put them into in this format, it becomes 5 dimensional tensor.
Okay, okay. Thank you so
Put
much.
them into here, this becomes 6 dimensional tensor. So this is all about representation. How efficiently you are representing your information in the form of number. Okay.
Thank you so much.
Okay, thank you. Anything?
Hello.
Yeah.
Any doubts, participants? You have any doubts? You can ask.
Let me know if you are having any problem or concerns.
Sir, no questions from the participants.
Okay.
Sir, Rajeshwari madam will take over the session, sir.
Okay, ma'am.
Okay.
Hello, sir.
Yeah, hello.
Sir, I'm Rajeshwari, Dr. Rajeshwari.
Yeah, madam, please.
So we're very grateful to have you for as a resource person for this 5 days FTP.
Yes.
All the sessions have been very informative, and you have explained the concepts with very good illustrations. I'm sure the participants will have gained the basic knowledge of artificial intelligence, machine learning, and also the mathematical foundations which are needed to work in these areas. Thank you once again, sir, for accepting our invitation.
Yeah. Thank you very much. But as my views on these things, I will be very much happy if at least 1 or 2 participants will come forward and start working on these areas.
Yes, sir.
Because most of the time, what we do now, something we learn and tomorrow we forget.
Yeah. I think some of them are already working in this area, sir. Machine learning.
So at least 1 or 2 participants, if they come forward and start working on this particular area, at least I will be very much happy, and I feel that my presence here and conveying the information about the basics introductory part.
Yes, sir. Definitely, sir.
Okay.
Thank you very much, sir. Thank you very much, madam.
Nice to interact with you. Thank you.
Okay. Thank you, participants. We'll wind up the session now. Okay. The next session is going to start at 11:45. Okay. So please join with the Google link, which I have put in the chat box. Thank you. Thank you very much, sir, for the information. Thank you.